Hello again, everybody. Welcome to a new screencast lecture. Tonight's lecture is going to be a little bit different. I'm going to be simulating an experiment since we're not able to be in a regular classroom, so we're going to do distance learning experiments today. The topic today is going to be conservation of mass, and we're going to do a couple relatively simple experiments to show the law of conservation of mass. Let's get started. We'll take a look at our overall content statement. The changes of state are explained by a model of matter composed of atoms and/or molecules that are in motion. The learning target is to understand that mass is conserved when substances undergo changes in state and form. Our first demonstration, we're going to need certain materials. We're going to use paper, a balance, and a data table that looks like this. We're going to record the mass of the paper before the change and the mass of the paper after the change. Before we do the experiment, we're going to read over the questions that we're going to answer. Let's take a look. Here are the questions. Things we're going to think about. We're going to think about how does the mass before the change compare to the mass after the change. We're going to think about if this was a chemical change or was it a physical change. And we're going to think about was this an open system or was it a closed system. Let's do the experiment. Okay, we're going to take a sheet of paper and we're going to put it on a balance. The mass of the paper is 5 grams. Then we're going to change the paper. We're going to crumple it up. Does it look different? Sure, it looks different. We'll put it back on the mass. And it shouldn't be a big shock to you, but the mass reads 5 grams. Okay, that one wasn't too exciting. Pretty simple. You probably should recognize that this was a physical change. The paper looks different, so it is a change. However, it's still paper. It's just crumpled up. No big deal. Now we're going to try a different experiment where this is going to be conservation of mass, phenolphthalein, and sodium hydroxide. Materials we're going to use for this one are a little bit more complicated. We're going to need an Erlenmeyer flask. We're going to need phenolphthalein solution, sometimes called phenol red. We're going to use sodium hydroxide solution. That's a very strong base. We're going to need a small test tube. And we're going to need a balance. And to top it all off, we'll need a rubber stopper to seal the Erlenmeyer flask. This is the data table we're going to use. We're going to record our quantitative data in this data table. We're going to need to know what quantitative observations mean. Quantitative observations are things that you can observe by measuring using numbers and units. So observing this piece of paper is crumpled up, that's not quantitative because we didn't measure it. We didn't see like how long the paper is or anything like that. We just said that it was crumpled up. That would be qualitative observations. Quantitative observations are going to use numbers. They're often going to use units. Some examples could be her hair is 32 inches long, the boy is 13 years old, and the man weighs 210 pounds. Notice these have numbers, and in this case, all of them have units. Before we do the experiment, we're going to read over these questions. When we answer these questions, we want to use actual data whenever possible. Number 1, compare the mass of the system before and after mixing. Does question 1 show a closed or open system? We're going to need to explain that. What scientific principle is demonstrated by the system before and after mixing? And we're going to need to describe an observation that we made that would give us a clue that if it's a chemical change or if it's a physical change. Okay, let's get started on this experiment. Here you see an Erlenmeyer flask, and an Erlenmeyer flask is the kind of flask that has kind of like this triangle shape. The flask here is filled with water and has some phenolphthalein in it, and then inside that is a test tube that has sodium hydroxide in it. Let's see what happens.
I did it in slow motion.
Oh, what? What?
So, what are some observations? We have a quantitative observation, which was what? Grams. Okay, so we measured what? Okay, good try. Yes. Mass. Very good. All right. All right. And the mass is 311, and it turned off again. I think the battery's really old. A qualitative observation.
No.
There's a bottle in the there's a smaller bottle.
Okay. All right. This is called a test tube. Very good. All right. Yes. You had your hand up. Give me a qualitative observation. That's right. Give me a qualitative observation.
Still yellow.
All right. You can see the yellow in there. Okay. Go ahead and put your hand underneath it. Just kind of hold it. How does it feel like temperature-wise? Yeah, a little chilly. Okay. All right.
Little channel.
Okay, so what about the main fluid? What color is the main fluid?
White. Clear.
Clear.
Liquid.
All right, clear colors. All right, here we go. You ready? This happens pretty quick, so. All right, you guys ready?
Yeah.
What?
I did it in slow motion.
Oh, what? What?
What about blue? Oh, he gets that's what they about
Oh, yes.
All right.
It's like wait, what did you sound?
Let's see what happens. Okay, what's our mass? 311 grams.
And it's pink.
And it's pink.
Or
Okay.
pink.
So 311 grams. 311 grams.
That's 300. That's
Looks like 34, doesn't it?
34. Yeah.
311 grams.
Yay.
The mass, you don't have to record this anymore, thank you. Yeah, we don't. Okay, hopefully you like that. Now you saw that the system before the change was 311 grams, and the mass of the system after the change was also 311 grams. The mass stayed the same before the experiment as it was compared to at the end of the experiment. Let's go over the questions and analysis. Let's start off with comparing the mass of the system before and after the mixing. That's just what I was talking about. So the mass before, at the beginning of the experiment, was 311 grams. And at the end of the experiment, it was 311 grams. Does question 1 show a closed or an open system? Explain. Well, hopefully you know the difference between a closed and open system. An open system allows matter to enter or leave the system. A closed system is sealed tightly, and matter, stuff can't get in, can't get out. This you should identify as a closed system, and you know that because there was the rubber stopper sealing the Erlenmeyer flask, so nothing could get in, nothing can get out. What scientific principle is demonstrated by the system before and after mixing? Well, since the mass of the flask was the same before and after the change, that sounds an awful lot like the law of conservation of matter. Well, that's what was shown. That states that the amount of mass before and after change will be the same. That's right. Our final question was to describe a clue that a chemical change occurred. The most obvious was that we noticed a color change. At the beginning of the experiment, the reactants were clear and colorless. There was a slight yellow tinge to one of them. After the change, there was a very bright pink color, so a color change definitely occurred. That's a clue that a chemical change happened. All right, well, that's all for today. The next time we're going to have another experiment that will hopefully show you the law of conservation of mass again. See ya!